Sulphonylureas like glibenclamide, gliclazide, these kind of funny drugs. They are insulin secretagogues, meaning what? Meaning they enhance the endogenous insulin release. So basically you have to have a pancreas that is working for this drug to work, right? Sulphonylureas work on beta cells. I think we've already discussed in the physiology section how beta cells work. Beta cells, they are located in the center of the islets of Langerhans, surrounded by the glucagon producing cells, which are called alpha cells. The beta cells, right, they do contain, if we take one beta cell, so they are in the center and they are surrounded by the alpha cells, right? These beta cells, they contain special channels in their membrane, right? So if we take the cell here, in their membrane, they have special channels. These channels, they are called, they have like a gate here. They are called ATP sensitive potassium channels. They are called ATP sensitive potassium channels. They are, as the name implies, they are channels for potassium and they are sensitive for ATP. What is the thing about it? What they do is that they allow potassium from within the cell to slowly leak out, right? Leak out of the cell, continuous leak, right? This means that these channels are important to keep the membrane hyperpolarized or in a polarized state, in a resting membrane potential state, because potassium is positively charged. So because these positive charges, that is potassium, is continuously leaking out of the cells, eventually all of the time the outside of the cell is more positively charged compared to the inside of the cell, right? So the majority of charges on the outside are positive compared to the ones that are inside, which is mainly negative. Now, in the normal situation, when glucose enters into a cell, it becomes metabolized, you know the case? And then eventually, if it is burnt by the cell, it will produce what? Energy in the form of adenosine triphosphate, ATP. This ATP binds to this channel, right? And close it, right? So this is Mr. ATP, suppose, right? This is Mr. ATP. This is Mr. ATP. And this Mr. ATP has his foot on the channel. It will close the channel. So what? If it closes the channel, no more potassium is coming out. No more potassium is coming out. No more positive charges are coming out. So the membrane is progressively becoming depolarized. It is progressively becoming depolarized until there is a point that is reached, right? That it becomes completely depolarized. When it is depolarized, other channels open. This other channel which open is voltage-gated calcium channel, and it allows calcium to enter the cell. And if that's the case, calcium will bind the vesicles that contain insulin and C-peptide and causes insulin release. So in simple terms, if you block the ATP-sensitive potassium channels, you will release insulin, right? That's the basic thing. That's how sulphonylureas work. They come and block this channel, ATP-sensitive potassium channel, and this will cause insulin release, endogenous insulin release. So if they induce insulin release from within the body, endogenous insulin, they will cause elevation in both insulin and C-peptide, right? Because these are present in equimolar amounts within the vesicles. So whatever amount of insulin is released, and an equal amount of C-peptide is also released, because C-peptide is a byproduct of insulin production. Did you know that insulin, it's initially a big, that is, molecule called pre-proinsulin, right? There's a big molecule called pre-proinsulin. Suppose this is the insulin, the real part that we want. The rest is just peptide, extra peptide chain. This is broken down to proinsulin. And then proinsulin is broken down into insulin, which is two chains but with two disulfide bonds in between, and C-peptide. Right? So it's a byproduct. So whenever endogenous insulin is increased, both insulin and C-peptide will be increased. Okay? So it means if sulphonylureas equal increased insulin release, if the patient is not eating, they can cause hypoglycemia. Is that right? They can cause hypoglycemia. So they are dangerous. Sulphonylureas should also be stopped, right, before the surgery, because patient will be kept fasting, right? So if the patient is kept fasting, that is 2 hours at least for clear liquids, and 6 hours for solid food. So patient is not eating anything. So if they take sulphonylurea, there's insulin, no carbohydrate, so hypoglycemia. So stop sulphonylureas before the surgery. What about, there's another class of drugs that we need to know about. These are called sodium glucose cotransporter 2 inhibitors. Sodium